Okay, so complement. All right, so what is complement? What is the complement system? So the complement system is a part of the immune system that enhances or complements the ability of antibodies and phagocytes or phagocytic cells to be able to clear microbes from the body. Okay? I know this is kind of a weird thing, just have to go over it several times. All right, so what it does is it promotes inflammation. It also can attack a pathogen's plasma membrane. So complement can do two things. It can promote inflammation in an area, or it can actually attack a pathogen's plasma membrane. Okay. So there's two pathways to this. Actually, there's three pathways. Sorry. All right. There's the classical pathway. There is the alternative pathway. And there is the lectin pathway. Okay, so the most common one is the classical. Okay, so the classical pathway has to do with antibodies. Okay, so an antibody, remember, looks like that, and it has like little, binding site receptor things on the little arms. Okay, it also has little binding sites here for what we call complement proteins. Okay, so complement is kind of a bunch of proteins that get together and do certain things. All right, so an antibody can bind specifically to a pathogen. Okay, this is the binding site, and it will bind to an antigen being presented on a pathogen. So let's just say it does that. Let's make that a different color. Okay, so it bound to its little pathogen here. And what can happen, and antibodies can do different things, but there are these little binding sites here, and it will bind to these little binding sites are called complement binding sites. So they bind to some kind of complement protein. And when it does that, it causes sort of a chain reaction thing. Okay? And it chain reactions to this main complement protein called C3. Okay? Now, the lectin pathway basically does the same type of thing, sort of. It just does it more specifically on the pathogen itself. It doesn't work through, like an antibody. So it binds sugars on the glycocalyx of microbes. And when these proteins bind there, then the same thing happens. And we get to this protein called C3. Okay? In the alternative pathway, we get direct, spontaneous hydrolysis of C3 on a microorganism. So we still get C3. I don't care. I'm not going to go specifically into these pathways. They're very complicated. It doesn't matter. Just there's 3 pathways, and it's going to end in, they're all going to converge into C3. Okay? They're all going to end up with C3 there. So there's certain things that C3 can do within the immune system. So C3 can be converted to C3b. Okay. And from there, it can basically go through opsonization, which is basically stimulating phagocytosis. Remember, opsonization is leading the phagocytes leading the men to the microbe or pathogen to be eaten. Okay. All right. It can also become C3A. So there's C3b and C3a. C3a will enhance inflammation. Okay. So we can get inflammation. We can get some phagocytosis here. C3b can also be converted to C5. And then C5 will combine with, or form a cascade and combine with other complement proteins, C6, C7, C8, C9, whatever. And they come together and form this thing that, I'm going to try to draw this and it's going to be awful. But this thing is called a membrane attack complex. Or a MAC. So the MAC attack. So this thing, if this is the little pathogen, it goes on here and then sits on here and then punches a big fat hole in the plasma membrane, and all this water and whatever comes in there and blows it up. Okay, so those are the three things basically that it can do. So basically, complement proteins can increase inflammation. They can be opsins and stimulate phagocytosis, and they can actually attack the pathogen directly through the MAC attack, or the membrane attack complex. So that's the important thing with complement. Understand that it's a bunch of proteins. It's there to, it uses antibodies and phagocytic cells to, kill pathogens. Okay, it promotes inflammation, it attacks the pathogen on its own, and it can cause phagocytes to do their thing, non-specific phagocytosis to occur. So understand that. I don't care if you know all the pathways. The classical pathways, the most common, you probably should be aware of that one. Just know that these two are here and do not have, and what that is, and do not have anything to do with antibodies. So these two, no antibodies. Okay, so when we get to the adaptive immune system and start talking about B cells that make antibodies, even though complement, this is an innate strategy. That's what antibodies do. Is antibodies go and systemically and use these general strategies from the innate system to fight pathogens when we're sick. Okay, so that's basically it for the innate immune system, and we'll be starting the acquired immune system.